Welcome back from the break. I hope you're ready to go because this is my favorite slice of the AI pie to talk about. And I'm excited to share that with all of you. Let's get started with natural language processing, or NLP for short. In this module, we'll start with an introduction to natural language processing, and then we'll move on to talk about the specific services inside of Azure that will help to execute NLP workloads, which will be covered in the section about natural language solutions. In this session, we will be discussing several of them and you will need to understand their purpose for the exam. Let's dive right into Lesson 1, Introduction to Natural Language Processing. Natural language processing, or NLP, is the area of AI that deals with making sense of written and spoken language. On the screen, we see a list of common NLP tasks. Let me start by talking about the first one, text analysis and entity recognition. Often you need to analyze a text document to determine its important features or identify entities that it mentions. Entities could be things like dates, places, people. For example, a company might use AI to analyze industry magazine articles to try and find articles that mention their products or their executives, or maybe to determine the main subject of each article. Or you may have noticed in emails how some key phrases are automatically underlined, such as dates, which might allow you to automatically set a calendar event. That is an application of NLP. Second, we have sentiment analysis. This is a common form of text analysis that calculates a score indicating how positive or negative a text extract is. This service can evaluate text and return sentiment scores and labels for each sentence. This capability is useful for detecting positive and negative sentiment in social media, customer reviews, discussion forums, and many other avenues. Using the pre-built machine learning classification model, the service evaluates the text and returns a sentiment score in the range of 0 to 1, with values closer to 1 being positive sentiments. And scores that are close to the middle of 0.5 are considered neutral or indeterminate. For example, if there was a restaurant review that sounded like, "We had dinner at this restaurant last night, and the first thing I noticed was how courteous the staff was. We were greeted in a friendly manner and taken to our table right away. The table was clean, the chairs were comfortable, and the food was amazing." The sentiment score might be closer to 0.9 or even 1, indicating a very positive sentiment. Whereas a review that goes like, "Our dining experience at this restaurant was one of the worst I've ever had. The service was slow, the food was awful. I'll never eat at this establishment again." Because of the usage of the words and the emotions that seem to indicate a negative experience, the score for this second review might be closer to 0 or 0.1, indicating a negative sentiment. Next, we have speech recognition and synthesis. It's becoming increasingly common to encounter AI systems that can recognize spoken language as an input and synthesize spoken output. This is applied in smart speakers and digital assistants on our phones that accept vocal commands and are able to provide spoken responses. Consider the growing number of home and auto systems that you can control by speaking to them, by issuing commands such as "turn off the light," and soliciting verbal answers to questions like, "Will it rain today?" So for example, your smart AI assistant can automatically start or stop music when you're driving to enable hands-free communication, or allow you to respond to a text by dictating a reply to enable hands-free communication. And number 4, we have machine translation. Nowadays, as we start to work more across cultural and geographical boundaries, it is required our ability to eliminate language barriers. And AI can be used to automate translation of written and spoken language. An example of this might be an inbox add-in that could automatically translate incoming or outgoing emails, or a conference call presentation system might provide a simultaneous transcript of the speaker's words in multiple languages. I've personally been in meetings where I've had participants who have spoken in Mandarin, English, Japanese, and German, and we were all able to use the Microsoft Translator to understand each other in real time. This allows us to be inclusive and sensitive to other cultures. And finally, we have semantic language modeling. Language can be complex and nuanced. So the multiple phrases might be used to mean the same thing. For example, a driver on the highway might ask a smart assistant on her phone, "Where can I get gas near here?" And this means the same thing as, "I'm running out of petrol." Or it could be providing the same answer as when she asks, "I need to buy water." All of those could essentially mean that she's looking for a petrol station or a gas station nearby. So a semantic understanding of the language being used is required to discern what the driver needs. An automobile manufacturer could train a language model to understand phrases like these and respond by displaying appropriate navigation directions to the nearest petrol station. Based on the possible tasks that machines can accomplish when it comes to processing language, all of these that I've just mentioned are also available for you to deploy to your own applications and workloads using Azure's off-the-shelf solutions. Let's begin by talking about conversational AI. Conversational AI is a solution that enables dialogue between an AI agent and a human. Conversational AI builds on other AI workloads, in particular, natural language processing. But it also has elements of machine learning and sometimes, potentially, computer vision as well. And in general, when people use the term conversational AI, they are referring to bots. People often associate the term bot with a chat interface on a website, but that is just one very common way to interact with a bot. Bots can also be connected to multiple channels, including email, social media, to the telephone, and so on. Bots are used in multiple different scenarios, such as customer support, for example, answering frequently asked questions, or gathering information before handing it off to a human customer service representative. You also find them in reservation systems. For example, it enables users to book cinema tickets or flight tickets, maybe even restaurant tables. We find bots in digital assistants. For example, an in-home or a phone-based virtual assistant that can perform tasks based on certain instructions. We can find them in online ordering as well. For example, when you order takeout food or for delivery or products from an online retailer, you're going to be able to sometimes encounter bots. And sometimes we also find healthcare bots. These healthcare bots can provide an automated diagnosis based on symptoms. And we find bots that help us to improve our office productivity, to find relevant corporate resources for a task. So why do we need to use bots? Humans are obviously much better at understanding nuanced, difficult questions. So they should be freed up to tackle more value-adding queries and doubts, not the usual frequently asked questions like, what time are you open? Or how much is product X? Where are you located? Humans waste a lot of time answering these simple questions when they could easily be found elsewhere. The example shown on the right side of the screen is a chat interface, such as one you might find on a website. But bots can be designed to work across multiple channels, as I mentioned. Regardless of the channel that these bots are deployed, bots typically manage conversational flows using a combination of NLP and constrained option responses that guide the user to a resolution. These conversations usually take the form of a message exchange in turns. And one of the most common kinds of conversational exchange is a question followed by an answer. This pattern forms the basis for many user support bots and can often be based on existing FAQ documentation. So to implement this kind of a solution, you would need to build a knowledge base of question and answer pairs, usually with some built-in natural language processing model to enable the questions to be phrased in multiple ways. Because these questions all mean the same thing and are going to require the same answer. So essentially, a bot service provides an interface to this knowledge base through one or more channels to be able to find that answer for the user. Azure's off-the-shelf services can help you to develop solutions and go to market and be more agile to reach your customers without having to reinvent the wheel and build a language model from scratch. The services you see on the screen are available on Azure and will allow you to start building and deploying your own NLP solutions immediately. They fall into the categories that we just discussed. Let's look at a few of them and see a demo of how we can analyze a piece of text using the language service towards the end of the module. On to lesson 2, the final lesson for today. We're going to look at how to build natural language solutions in Azure. Now let's look at some NLP solutions that are ready to use off the shelf. We start with text analytics. Text analytics is a capability in language service that is used to analyze input text documents. When we read a sentence, we are looking out for several things like what are the key phrases in the text? What are perhaps some names and references? Is there some emotion being expressed by the text? Those are all things that humans notice very well. Our challenge now is to get AI to try and do the same thing. And it is very complicated to program it from scratch. So being able to use them off the shelf greatly simplifies your development process. If you're trying to create something new for your marketing, for your document analysis, maybe your social media management, or any other purpose that you can think of that you might be using it for. Suppose you can use text analytics to analyze the text on the screen. I had a wonderful vacation in France. Generally quite positive, but let's see how it would get analyzed. So the first thing that will be analyzed is the language. The service determines the language that the text is written in, so it has high confidence that it is written in English. Next, we are able to get the sentiment of the text. In this case, it was largely positive, 88% positivity. So in a scale of 0 to 1, it would fall at 0.88. Next, we also find key phrases, and the key phrase here is wonderful vacation. And finally, you can pick up entities in the statement. And the entities here are France. This is a very simple example. But imagine if you had to analyze Twitter for mentions of your brand or your company, and you have several thousand comments to analyze. A service like this would greatly speed up the process and help you to analyze your data and harvest the information in a much quicker manner to draw any insight that you need to take future action. The next service we're going to be looking at is speech recognition and synthesis. This is concerned with vocal commands and spoken responses. Recognition refers to the ability to recognize, detect, interpret spoken input. And synthesis is the ability to generate spoken input, to form sentences rather. So think smart speakers, AI assistants that recognize when you ask them to turn off the lights, or they recognize when you ask them to play a song by speaking to them, and they can also synthesize appropriate responses to you. Like when they do find the song, or when they cannot find the song, they apologize to you. The speech service provides a speech-to-text API to perform real-time or batch transcription of audio into text. This service supports text transcription in more than 60 languages. Conversely, the text-to-speech API can synthesize audible speech from text, with the option to specify regionally appropriate voices for human-like pronunciation. When you use the text-to-speech API, you can specify the voice to be used to vocalize the text. This capability offers you the flexibility to personalize your speech synthesis solution and give it a specific character. The service includes multiple predefined voices with support for many languages and regional pronunciation, including standard voices as well as neural voices that leverage neural networks to overcome common limitation in speech synthesis regarding intonation, resulting in a more natural sounding voice. You can also develop custom voices and use them with the text-to-speech API. As organizations and individuals increasingly start to collaborate with people from other cultures, We need to remove language barriers because it has become a significant blocker. And one solution is to find bilingual or even multilingual people to translate between languages. However, that kind of a skill is quite a scarcity. And the number of possible language combinations can make this approach difficult to scale. And increasingly, automated translation,
in this video,
sometimes
I'm going
known
to
as
demonstrate how
machine
to create
translation,
an
is
online
being
RMA.
employed to solve this problem.
process should only be used
Decades
if you
ago,
are certain
if
that
you
you are
used any of
facing a
these
hardware failure
translation services,
on one of the products in
you
this
may have
table.
noticed how the translation was
This
often
process is limited
literal,
to hardware replacements
sometimes
only.
word for word,
If you
which
would like to
can
complete
lead
a
to some
hardware
embarrassing
replacement,
and funny
select
situations.
the product and
With
click Create
advancements in the
RMA.
field of AI,
Please
semantic
review
context
the
has
online
allowed the
RMA
service to
guidelines
return a more
and confirm
accurate
your acceptance
translation
of the terms
the
and
input
conditions
phrase
by
or
selecting the
phrases.
checkbox.
The grammar rules,
Click Confirm.
formal versus informal, and colloquialisms
After
all
confirming
need to be
acceptance
considered
of the
when we're
RMA
talking about
guidelines,
language.
you'll be asked a series
For
of
example,
questions as it pertains to
in
the
English,
hardware and
we say,
troubleshooting
"I
that was
kicked
performed
ball."
to isolate the hardware issue.
And in my mother tongue of Tamil, the order is slightly different. It would be arranged I, ball, kick.
If at
So
any
slightly
point in
different.
time you need to revert to
And
the
the
standard
translated
technical
text
case
service
creation
enables you to
workflow,
translate
click
text
Cancel.
between more than 60 languages. You can also translate audible speech by using
Please
the
review
speech
and answer the
service,
questions to
which
help
can
us
produce
determine the hardware
translated
fault.
output in text or audio format.
As you're answering the questions,
It can also
it will be
output
determined
both
if you may
speech and
proceed
text
with the online RMA
from the
process
input
or
speech.
if you should create a
The
technical
language
case.
understanding service
In this
enables you
instance,
to
we will
train a
proceed
language
with the
model
online
that can
RMA.
interpret natural language commands. As
After
artificial
completing all of the
intelligence gets
questions,
smarter,
if it is determined you are
interactions with
eligible to submit
applications
an
and
online
digital assistants are
RMA, you'll be
becoming more
required to
complex.
upload available log files
And in specific
pertaining to the
scenarios,
hardware
can
problem.
result in human-like interactions with AI agents. Common scenarios for this kind of solution include
Identified.
customer
You can
support
upload the
applications,
files or you can
reservation
drag and drop.
systems, and home automation, amongst others. To enable these kinds of conversational
Please
solutions,
note that the max file size
computers
is 2 gigabytes.
need to be able to
If you
accept
need to upload
language as
files
input,
that are larger
either
than 2
in text
gigabytes,
or audio format,
Attachments tab
while
may process
also
necessary
being able
files
to
have been
interpret the
uploaded. You will
semantic
see them
meaning
below.
of the input and understand what is
If you
being
do not
said.
have the log files,
On
provide
Microsoft
reasons
Azure,
for files
language
and
understanding
select
is
the
supported
appropriate
through
reason.
the language understanding service.
To continue,
To work with the
click
language
Create
understanding
RMA.
service, you need to consider
The
three
next step is
core
to review
concepts,
and confirm your
and you
shipping
will
address
need to know them
details.
for the examination.
Please review this information
First
carefully.
are utterances.
And if there is a change,
Utterances
please,
are phrases that a user might
if you change
say
the
or
address,
type.
you
For
have the
example,
option to change
switch
the
the light
installed
on.
base address
That's an
permanent. So
utterance.
choose that any change to the
Entities.
processing of your
Entities are
RMA.
specific items that are referenced
If
in
the
an
selection-
utterance. For example, a language model
You will
for a
then
home
need to
automation
confirm one
application
more time
might
in order to
recognize
create your online
household
RMA.
devices,
Your
such as
tech
a
case
light
and
or a
related
fan.
RMA have been successfully
And finally,
created
intent.
and automatically processed.
Intent
You will
identifies
also
the
receive an
desired
email
action
confirmation
or the
updates
goal
on the
of an
RMA.
utterance.
Clicking on
And in
related.
this example, it is to switch the
Number
light
to-
on,
if
to
there
switch
are-
something on.
Replacement.
Common
Thank you
scenarios
for
for
your
this kind of
attention.
solution include
This concludes
automated
this
phone
training.
banking and smart homes. And then we come to question answering. This cognitive service enables you to create and publish a knowledge base that is a question and answer bank, usually with some built-in natural language processing model that enables questions to be phrased in multiple ways to be understood with the same semantic meaning. You can use the Q&A Maker portal to create this knowledge base that consists of these question and answer pairs. These questions and answers can either be entered and edited manually, or they can be generated from an existing FAQ document or web page, or they can be imported from a predefined chit-chat data source. And in many cases, a knowledge base is created using a combination of all of these techniques, extending the knowledge base with additional manual entries. Questions in the knowledge base can be assigned alternative phrasing to help consolidate questions with the same meaning. For example, you might include a question like, how can I visit your head office? And you can anticipate by adding an alternative phrasing such as, where is your head office? Different words, same meaning, same question. After creating a set of question and answer pairs, you must train your knowledge base. This process analyzes your literal questions and answers and applies a built-in natural language processing model to match appropriate answers to questions, even when they're not phrased exactly as specified in your question definitions. After this training, you can use the built-in test interface in the Q&A Maker portal to test your knowledge base by submitting questions and reviewing if the right answers are being returned. And you can go ahead and publish it so that the client applications can use it. That is the Q&A Maker. And then we have conversational AI solutions that focus on interactions between human users and AI agents. And these are called bots, which brings us to the Azure Bot Service. There are several ways where we can deliver a conversational AI solution. It could be using a client application or a bot. By encouraging our users to interact with the AI agent, we free up our human agents to do more value-adding network. And a bot developer can use several tools to develop and build a bot, including using Power Virtual Agents, Bot Framework Composer, or Bot Framework SDK. This bot then gets integrated with the Azure Bot Service and the Azure Cognitive Services in the cloud. So the bot can make use of capabilities such as question answering and get published. A bot is an application with a conversational interface, so they could be deployed on a whole host of deployment channels, such as a web chat, an email, Microsoft Teams, and others. With that, we come to the end of Module 4. But before that, let's jump into the Azure portal one last time to see a language service demo, shall we? So once again, we shall go into the Azure portal to create another service. This time we're going to be doing some analysis of language. And for that, there's another special service. It is the language service. So let's go ahead and select that. Language service, again, is a standalone service, not like the general cognitive services which can be used for all services. I'm going to create this. And when you're selecting the language service, you can select additional features. So if you were building a bot, for example, you would select the custom question answering. Or if you had some specific niche requirements, you might require custom text classification and named entity recognition. But this time we're just doing very straightforward analysis, so these default features are sufficient. So I'm not going to select either of these. I'm going to go ahead to continue to create my resource. So again, I'm selecting my own subscription, and for resource group, I'm going to use the one that we've been using for this entire demo session. And I'm going to deploy it in the East US region. I'm going to give it a name, Language Service AI-900 Demo. Make it nice and easy to recognize in the future. For the pricing tier, I'm going to select free, since it's available. And of course, you need to accept the responsible AI notice. I'm going to accept this, and we can go ahead and review and create this service. Simple as that. So when you click review and create, it will validate that you are allowed to create this resource and all the configuration is proper. And go ahead and click create. To my code editor and modify this code, and this time we are using the analyze text script. It's again inside there, analyze text, and we need to replace the key and the endpoint. Nice and easy. So you can use either key, it's perfectly fine. I can use key 2, it'll give me the same results as key 1. And replace my endpoint as well. And that's it, we are ready to go. So let me go ahead and save this and close the editor. So there's some text that I'm analyzing, I mentioned that it's a review that I'm analyzing. So let's pull up that review so that you can see it side by side. So on the right, you see the review text that's going to be sent to this language service. I'm going to expand my Cloud Shell a little bit more because there's going to be a bit of information that we're going to get. And the review says it's a good hotel and staff, the Royal Hotel, clean rooms, good service, great location near Buckingham Palace and Westminster Abbey, and so on. So generally a very positive review. So if we feed this into our language service, let's see what we find out. When we analyze text.ps1, so this is the script that we're going to be consuming, and this is the review that we want to analyze, review1.txt. All of this is inside the folder in our Cloud Shell. So when I hit enter, it's going to do a couple of things. So first you see it detects language, it finds key phrases, it analyzes sentiment, and it found known entities. So let's go up and read all of this stuff. And just to highlight, you don't have to do this inside Cloud Shell. You could do it from an application that you're building, you could do it from your own computer, a web application. There's many ways to consume this service. I'm just doing it in the Cloud Shell. So first, it found that it detected the language. So it has a 99% confidence score that this is an English review. So yeah, I think that's pretty accurate. And then it found key phrases throughout the entire review. So things like the Royal Hotel, Buckingham Palace, Westminster Abbey, Michelin star, anything that a human reading this, their attention may be attracted towards those things, the AI also picked up. So it dropped out words like we and went and to, so on. Those are kind of unnecessary words. They don't really add that value. They're just for the purpose of grammar. And then we have the sentiment of this review. So its sentiment is a positive sentiment based on these scores. So 98% positive, 1% neutral, and 1% negative. And it identified known entities. So the entities that it recognized are good music, hotel, Royal Hotel. So if you're doing some research, this would be a very useful way to go about doing that. Now let's go ahead and feed another review to this script. So this is another review, also of the same Royal Hotel, but this time not so positive. So it says tired hotel with poor service, the Royal Hotel, London. This is an old hotel and the furnishings are average, becoming a bit old now and require changing. So let's feed this review into our script and see what happens. I'm just going to modify the previous command that I did. So I'm going to send it to analyze text.ps1 review 2 and hit enter. It's going to do the same couple of things, detecting language, finding key phrases, sentiment, and identifying known entities. So a little different this time. Let's go up and go through this again. So again, it detected the language, and this time it's 100% certain that it is English indeed. And then it found key phrases, again, Royal Hotel, tired hotel, old hotel. So all generally negative things that it picked up, and some entities that it recognized. And then it analyzed the sentiment, and this time we have a very different sentiment. It's a negative sentiment based on these scores. 1% positive, 7% neutral, and 92% negative. And this would be quite accurate. This is the same feeling that I would get if I was reading it. And the known entities have also been given Wikipedia links for you to do some research on. And this is how you will be able to use this service. And you can imagine using this for many other applications. For this example, if you said a human could read it and understand it, I agree with you. But imagine if you were trying to understand the sentiment or that the world was thinking about your company, and you had to go to Twitter and you picked up 1 million comments. And could we sit down and really go through one by one all of those and figure out whether it's a positive or negative sentiment? So applications like that, the language service can really come in handy to help carry out this job. So often it is used in marketing, it's used in analysis of sentiments. And so let's go back into our portal and wrap up this module. As you can see, the language service is a very useful tool with a lot of potential for building applications. So go ahead and try to build something yourself to see how easy it truly is. And that is a wrap for Module 4. In Lesson 1, we got introduced to the concept of natural language processing. And we had a short discussion about NLP and conversational AI. Following that, in Lesson 2, we saw several NLP solutions inside of Azure, such as text analysis, speech recognition and synthesis, translation, and Azure Bot Service. Which brings us to the end of today's session. I would like to thank you for attending this session. Artificial intelligence is a huge topic, and today's session is just the first step in this long journey. I hope you have found this session useful and have a greater appreciation for AI. And since you've stuck with me through to the end of this session, I highly recommend signing up for the AI-900 examination. The questions are going to come from the same great content that we've covered across these 4 modules. And since it is a fundamentals course, you only really need to focus on identifying and describing the different AI components inside of Azure. I highly recommend that you check out aka.ms/AzureLearn_AI fundamentals to revise the content that I've covered in today's session. I wish you all the very best as you prepare for the AI-900 examinations. I think that's pretty much everything that you need to know while preparing for the examination. Again, review any areas that you might be unsure about with the learning path at aka.ms/AzureLearn_AI fundamentals. And make sure that you share that shiny new badge on LinkedIn once you pass your exams. Once again, thank you so much for taking the time out of your schedule to join us for this session. Good luck with your exam, and I hope you have a fantastic rest of your day. And hopefully we'll be celebrating a new badge or see you in another class really soon. Bye everyone. Welcome back from the break, folks. I hope you got to move around a little and digest all the information that we covered in the first 2 relatively heavy modules. In Module 1, we got introduced to the concept of artificial intelligence and the different applications of AI. In Module 2, we got to look at one such application, machine learning, and we got an insight at how we could build out the solution inside of Microsoft Azure. Moving on to Module 3, we'll be exploring the fundamentals of computer vision. Computer vision is one of the core areas of artificial intelligence, with a strong focus on allowing AI to receive visual input and see the world to make sense of it and allow us to build out applications and solutions. In Lesson 1, we will discuss the concepts around computer vision and how it functions, and then move on to discuss the solutions in Microsoft Azure that can help you to integrate computer vision workloads such as facial detection, object recognition, and analyzing forms, and several others into your own applications in Lesson 2. In the first lesson, I'll talk about what is computer vision and give you an understanding of how computers receive visual input and some common applications of how this input is processed for useful work. So, what is computer vision? How do computers see? Humans, we use biological eyes to see and process images in our brains to understand the world. Computers use cameras to obtain visual input through digital images such as photographs, live camera feeds, or recorded video files, and then process these incoming images and video feeds using software models. AI applications are then further capable of making sense of these images by using patterns that they've observed from past samples, and they assist in carrying out various tasks, such as recognizing what's in the image, sorting out which part of the picture certain objects are occupying, etc. An image is separated into an array of pixel values. This is how it's segmented. And every one of these pixels is providing information in the form of numeric values, indicating the color intensity in every pixel in the image. These values are then used as features by the machine learning or AI to process and understand the image. Each digital image is represented as an array of numeric values indicating the color intensity of each pixel in the image. Sometimes images are converted to grayscale for ease of computation. In the case of color images, there are 3 layers of pixel values for red, green, and blue intensities. You can then use these color intensity values just like any other data as features to train a machine learning model or to